Hello and welcome to my channel. Today we are with part 8 of the series Fun with Logic in Learning ForTran. Today we will be having some quiz. So it's a quiz time 3. In my earlier PCTF day 1 part 2 video and in my earlier Fun with Logic videos, some of the quiz have already been given, and today's quiz time 3 on array and subprogram. In this series, episode 6 and 7, we have learned the array and subprogram. So today we will be discussing some of the tidbits and bits of these two concepts, particularly in some cases how to play with logic, and more importantly, what are the probable mistakes that we usually do at least in the beginning, and how to be careful at what points you have to be careful, and how to carry out the correction as well. So quiz time 3. The first one, what do the following program segments do? So we are going back. Actually the program is given to you and you have to trace back what the problem was. So it's a loop over k 1 n 2. So the interval is 2, mind that. Now t is ak. So ak is on the right side, that means it is predefined earlier in the part. This is only the segment, it's not the full program. So ak is already defined as an array. Now you are saying that t is ak. K is 1, the first one. So a1 is assigned to t. Now a1 ak is a k plus 1, that means a1 is now a2. And what about a2, that is a k plus 1? It is equal to t. Now what was t? T is the first one, it's a1. So a2 is now a1 and a1 is a2. So it's an exchange between 1 and 2. Fine. Now it comes to 100 continue and goes back to do 100k equal to now not 2 but 3, because 1 n at the interval of 2. So it is now 3, and it does the same thing as it did for 1 and 2. Now it will be doing for 3 and 4. So now you can conclude probably that okay, the problem is that it goes on exchanging values between 1 and 2, 3 and 4, 5 and 6, and so on up to n. So let us check. Yeah, it is the interchanges the values of a1 and a2, a3 and a4, and so on. Okay. The next one, here again t is a1. Now it starts the loop over k 1 n minus 1, and here by default interval is or increment is of 1. That means it takes up k equal to 1, 2, 3 up to n minus 1. Now ak is ak plus 1. So that means a1 is now a2, takes up the value of a2, and a2 ak plus 1, a2 takes up the value of t, where t is a1, right? So a2 now becomes a1 and a1 becomes a2, interchanges, right? And then it goes back to again k equal to 2, and now a2 is a3 and a3 is t. So it goes on like that, and you can check it that actually the task is okay, the final statement an is t, finally an. So you see it does 1 to n minus 1, say n is 5, so it does for 1 to 4, and then finally a5 is t, that means a1. So the task is basically like this. So a1 takes up value of a2, a2 takes up value of a3, and so on. Finally an takes up back the value of a1. So it's a cyclic permutation, right? Let us go to the next problem. What do the following program segments do? So it's rather straightforward. It's a summation. Sum 1 is 0.0, that means initialization of the variable sum 1. We often call it Phaka Judi, and then it goes over 1 to n, and it does repetitively. It adds on ak, that is a1, a2, a3 to the Judy, that is sum 1, and it ends. So you are getting actually the sum of n number of variables which are stored in an array A, K. Now finally you are doing the average, that is sum 1 by float n. N is integer, float makes it real, so it's real by real and it gives a real value. And then again another loop, another initialization, variable sum 2, another Judy sum 2, Paka Judy because it is 0.0, and then it does something repetitively again because sum 2 is sum 2 plus, that means repetitive sum. And what does it add on? AK minus average. So in the earlier loop you have got the average. Now here it takes the difference of each A value, AK, and average, and then makes it square and then add. So that is actually you can say that it's the sum of square of what? Individual value minus the average value, it's square. And of course you can understand that actually is trying to define the summation is nothing but the variance when you divide by float n, that is average, and standard deviation is square root of variance. So your answer is that it's computing variance and standard deviation, right? Well, probable mistakes, simple mistakes, nothing to do with logic that much, but you are very prone to the errors to start with, this kind of errors. So read 5 comma star comma etc etc. So the answer is given that well, this comma is invalid somewhere here, so comma is not here, right? And another thing is okay, and then write 6 comma 20 comma. So again comma is the problem. Another problem is here because I equal to 1 to n3 and aij, so it's using some implied do loop kind of thing, but the bracket number is not clear. So a bracket should be here or here. This a bracket should be here and it should end with another bracket. So that is the error. And in the third, if you see it carefully, you will find no error. And the last one, this k plus 3 is something wrong. You cannot use k plus 3, rather you can define an earlier variable kk as k plus 3 and you can write kk here, right? So lkk and k is 4 to 10 etc, but kk is defined earlier, not here. Okay, so this is the error type. Now it's an exercise because otherwise it will take time, but best way to handle this kind of exercise is that what Rahul calls it dry run. So you just put the values one after another for different loop, say one column for the first cycle, then second column for the second cycle, and so on. And then if you go on like this, you will get the answer to be like this. So the answer is provided to you, you just check it. Okay. This is also an exercise. Consider a square matrix n by n, and what does the following program segment do? So again, it's an ideal case of dry run. You just put the value that what happens to k for each I, you just write side by side and what it is doing actually. So exercise, though the answer is given, that it prints the elements of A above the diagonal. Okay, so that is the job done here. And another exercise, that suppose A is an n by n array, then you have to write a subroutine to store the elements in the upper triangular part of A, including the diagonal ones. So into a linear array B. Of course, the number of elements in that case would be n into n plus 1 by 2 elements. So that means you have been given a square matrix and you just pick up the elements which are upper triangle elements. That means the upper triangle include the diagonal elements, and then all these elements in order you have to store it in a linear one-dimensional array B. So you think over it, though for your help the subroutine is supplied here. Okay, and then what do the following segments do? So let me discuss it quickly. Okay, it goes for over k up to n with the increment of 2. Okay, now some check criterion is there, and it tells that if the k, that means first a1 less than ak plus 1, that means a2. So if a1 less than a2, then go to 99, that means it will continue. Okay, let us check the other way. If it is not so, that means if a1 is not less than a2, then what happens? Then actually this logic we have used so many times, it is an exchange. T is the temporary variable, ak is assigned, then ak and ak plus 1 exchanged. ak is taking up the value of ak plus 1 and ak plus 1 is getting the value of back of ak, that is which is stored in temporary variable t. So it's an exchange between a1 and a2 to start with, provided a1 not less than a2. Okay. And if it's so that it is less than a2, then you go to 9, then it will not do the exchange and 99 will be continued. So the task was interchanges a1 and a2 only if a1 greater than a2. But then what happens after the first cycle? It goes k equals to 3. So 1 and 2 is done. Now 3 and 4, like 1 and 2, so 3 and 4, right? And then so on, 5 and 6. Of course, in each case, it would check whether a3 is greater than a4 and so on. Okay. This is given as an exercise. Well, again, a temporary variable is declared, but this time this index are a bit tricky. So you please think over the problem and you will get the answer like this. Okay, it's given. Now the next problem. Find errors, if any, in each of the following subprogram defining statements. Subprogram defining statements. So we know that what subprogram defining statements, it's like this. Function next a b plus c x, and the next one is function grade a b c. So of course the comma here is something wrong, and then whether b plus c, is it allowed in this defining statement? Let us see. Comma after function is wrong and b plus c is not allowed in defining statement. You can declare d equal to b plus c and then you can write d here, but not b plus c as such here. And the next one, of course, function subroutine, grade is the name, and it should be within a parenthesis, a, b, c the arguments. So should be in parenthesis, right? And then the third one, again I think this y3 cannot write here in this argument list, and here subroutine u, v, w. Oh well, there is no name, subroutine and then u, v, w. So let us check the answers. Yeah, y3 cannot be a parameter in defining statement, and no name of the subroutine in the fourth problem. Well, another set of finding errors, if any, each of the following subprogram defining statements. So function xxx a and k. So okay, the same type of, so I am leaving it for exercise. The answers are of course given to you. Here a program segment is given and it's calculating something using a single subprogram. So you see 3 jobs. So far 3 jobs are here mentioned, R, S and T. But you are asked to use only a single subprogram. So how it can do it? Of course, the first thing that if you are to use a single subprogram, then of course the job pattern would be the same. Only the inputs would be different, output would be different, but the functional form between input and output must be the same. So can you find that kind of similarity out of all these 3? Yeah, because in each case it is something square, y square, and then it is again some square, much 5 square, then s 4x square 9y square minus z square, and here again x square plus y square minus 6 square, and then finally square root. So if you write a subprogram, actually you can do this subprogram in many ways, but for example one such would be like this, that you are writing a subprogram like this. So function cal is name of the function. Now x, y, cx, cy, they are the inputs. X, y, and cx, cy I am defining that these are the coefficient 4, 9, here 1, 1, here 1, 1. So you are multiplying x cx square plus y cy square minus c square. C is the 6 square or 5 square or z square. So this is the general pattern. That's why the subprogram or these are called dummy variables, because some cases it will take some other value 4, 9, in one case is 1, 1, etc. and then return n. So this is the subprogram sketchy way. And now the ForTran segment can be like this. That is the main program part. That when you are calling first time for R, it is xy 1 1 because the coefficient are 1 1, and it is 5 because c is 5 and it is c square. So c square, so 5 square. And in the second case, s is 4, 9 and z. So 4, 9 and z. And the third case again 1, 1 and 6. So it is 1, 1 and 6. Okay. And finally T1, after you get T1, you take the square root of T1 to get the T value that is as demanded in the problem. Well, that's how we demonstrate that how a subprogram can be so powerful. Well, the next job is, it looks something difficult, but it's not at all difficult. Actually follow the same pattern, that using a subprogram. Here it is a function subprogram. So your task is to find this s value, and it includes sum over square xi square and yi square, and this is xi yi. So you may be tempted following the last problem that okay, I have got it. I have to have a program, subprogram, which actually will do this job, a and b, ai bi. So ai bi, that means xi yi. But what about yi square, xi square? Well, it's very simple. If you take both a and b, they are dummy index. So both a and b, if you take in your parameter both x, then you will get x square. Both y, then you will get y square. So it's a point that when you are calling the subprogram, then you have to be careful that what you want, x square, y square or xy. So accordingly you have to put the a b values. So let me check. Well, the function pro in a b n. So a b, and it goes from 1 to n. So you have to declare all the input a b n, and no output in the parameter list, because it's a function subprogram. So the output would be stored in the name pro in. Let us see how. So you have to declare the dimension, because a and b both are dimensional variable, subscripted variable. Then you have to make a loop taking the product of the terms for ith term, I is 1, 2, 3 and so on. So and then not only take the product but go on adding. So you have to have a phaka judi, an empty box which is initialized in the name proin to be oh, it's wrong, it's oh, it's 0. So we are adding, so 0 is the initialization. So proin is proin plus this product, and 10 return and end. One thing you notice more, that here I am using dimension a n, where n is getting through the parameter, so it's not a constant but a variable. So I am using a variable dimension that I discussed in the last episode. And now the ForTran segment. So you will be actually calling 3 times the same subprogram 3 times. One is for this, another for y square, another for xy. So you see, up 1. So here 2 things. So up 1 is square root of proin xy n. Square root is there because x square, and up 2 is square root of okay, some square root is missing, I think some square root is missing here. Okay, according to the problem we can change the part, and down is square root of this. So the whole things actually under square root, and then s is up 1 into up 2, this 2 part, and then down part is by down part. So that is the thing, how one can use the sub program in a main a number of times as and when needed. So another one is given as a task, that is it includes the problem of Newton rupture actually, that supposing that you have a function for evaluating the function value funcn function, and another is d function, that is derivative of the function. So the problem goes like that: assume the subprogram funcn and dfuncn are already there, where these two evaluates the function fx at x and the derivative fx at x. So you have got the two function and derivative values by just calling two function subprogram in your another subroutine subprogram, where you are calling actually these function subprograms to evaluate the x new, which is needed for Newton-Raphson method. So once you go through the Newton-Raphson methodology and then you come back to the programming aspect, you will understand it better. Okay. Now, suppose the following subprograms are given. Subprogram following subprograms, that means more than one. Yeah. So it is another one which is a subroutine add and function sum. And what do they do? The function one, it just give you the x plus y plus z, but as well it does something else also. X, y and z, they are redefined according to these statements. Okay. So the function subprogram gets x, y, z from the main, and when it gives it back, the x, y, z are no more the older one but the new values. And here in the subroutine add, what it does, total. So again total is x plus y plus z, but that it does after redefining y, z and x. Here sum was done earlier and then redefined, and here redefined first and then the summation is done. Well, what is the problem? The problem is that you have to find the output of the program segment with the given input for A, B and C as 1, 2 and 3 respectively, but you have to use this sum function subprogram in the name of amount, and then you have to call this subprogram, call add abcgt, and then finally you have to write abc amount and gt. So other than this xyz redefinition part, the program is as such very straightforward. But because these are redefined here and there also, so you have to be very careful, and it's better to run parallel dry run by writing side by side. But what happens? Say for example, here when it calls the sum here, so after getting the sum y, z and x, right, they are redefined. So y is x, it should be plus, sorry, y should be x plus y. So that means you see A, B, C in order it is x, y, z. So A, x, B, y and C, z, one-to-one correspondence are there, and similarly by that way B is A plus B, because x is y, x plus y. So A plus B, so A1 plus 2 is 3. So B is now reassigned to be 3. Now C, so Z, C is B plus C. Okay, so B is not anymore 2, but in the earlier line B is redefined to be 3. So it is 3 plus 3, because C is still 3, so 6. Follow the color please, and then A, because X. So A is C plus A. Now C in the meantime has been changed to 6, and A is still 1, so 6 plus 1 is 7. Now it's turn of subroutine add. Now what happens? Here again the exchange, redefinition goes on. B equal to A plus B. Now by the same way, if you are careful, if you have used the latest value of, that means the redefined or reassigned values of the variables, then you will see the answer that B is now 10, C is now 16 and A is now 23. So you have to write in the last step A, B, C. So A is 23, B is 10, C is 16. So 23, 10 and 16, and finally 49. 49 is the GT. Now GT is the total, because GT in calling program it is GT, but in program actual total it corresponds 1 to 1. So GT is nothing but total, that means x plus y plus z. That means here A plus B plus C. but A plus B plus C is 23, 10 and 16. So if you sum, add up, you will get 49, right? So it's not that much to play with logic, rather it's more with, you can say it's a game of patience, a game of carefulness, game of bookkeeping to some extent. So this is also very much part of your programming requirement. And finally, we will be doing something very interesting, that which I myself recently, you can say, discovered. It was there in ForTran, but I didn't know. I was not interested in that problem earlier. That is the storage and display. Okay. Okay. The first one is a rather simple one, that determine the number of elements in arrays, 3 array A, B, and K, according to the dimension statement. So dimension statement goes like this: A 25, B 384. It's a 3-dimensional array, and it's a 2-dimensional K 7, 5. So what are the number of elements in each array? So the first one is straightforward. A 25, that means it reserves 25 locations or space, memory space. So maximum 25 variables allowed. But what happens to say K 7, 5? So as you know that the 2-dimensional array is nothing but practically it's a 2-dimensional matrix. So if it's a matrix of order 7 and 5, 7 cross 5, then of course the number of elements is 7 into 5, that is 35. So here also the answer is 35. And by same logic, B, the number of elements in B array must be 3 into 8 into 4, that means 96. So the answer is 25, 96 and 35 elements. Well, that's the starting one, but the more interesting part is coming here, that how the elements are stored in a X array, X of say 4 cross 4 or 4 by 4, right? This is the question, how the computer stores at the fundamental level. Well, so 2-dimensional, so it has 2 indices I and J, so I and J. Now the rule is that it exhausts first the row, that means I, and then column, that means J. And if it's a 3-dimensional, then it comes the third one, that means we call it page. So then comes the page. So I, J, K, I first, then J, then K. And for ij, it is simply first I and then j. First I means that I would exhaust itself first for a fixed j. Okay, it goes on like that. For example, 1, 2, 3, 4. So I is a 4 by 4. So I varies from 1 to 4. So it takes all I values, possible I values, 1, 2, 3, 4. But at the same time, what about j? J is the single value, that 1, 1, 1, 1. So for j is 1, it exhausts I, 1, 2, 3, 4. Then what happens? Then j will change, j would be 2 and I again 1, 2, 3, 4. So in green color 1, 2, 3, 4 and it's 2, 2, 2, 2. And then now you can get the idea that again I is 1, 2, 3, 4 in purple, and again j is now 3, 3, 3, 3, and finally I 1, 2, 3, 4 and j 4, 4, 4, 4, right, in a different blue color. Well, that means it goes like the element 1, 1, then 2, 1, then 3, 1, that means the column wise, then 4, 1. Then 1, 2, it goes to the second column, then 2, 2, 3, 2 and 4, 2. The second column is exhausted and so on. It will be more clear if I give an example. Suppose my 4 by 4 matrix is like this, right? So the first row, if I write in this way, the red and different colors are used for different rows. But what happens, because it comes like this, the pattern is 1, 1 and 2, 1, that means 5, then 9, then 13, right? So 1, 5, 9, 3. According to this pattern, actually the values is 1, 5, 9, 3. So that is the storage pattern. Now you can display your results as per your own choice. That's a different thing. But the storage goes like this. And then the second column 2, 6, 10, 14, 2, 6, 10, 14, and then 3, 7, 11, 15, and then 4, 8, 12, 16. So 3, 7, 11, 15, and then 4, 8, 12, and 16. Okay. So this is how a 4 by 4 matrix or array is stored. Now, what if X is declared 4 by 4 in the main program, but 3 by 3 or something lesser than 4, say 3 by 3 in sub. So that means I am talking about a variable dimension, right? So in the main it is 4 by 4 declared, but in the subprogram it is declared as 3 by 3. Okay, but the arrays are having one-to-one correspondence. Okay, then what happens? So I am talking about variable dimension in subprogram, and the trouble. It is in principle it can be done, but the trouble is there. So let me discuss that. So dimension in the main is 4 by 4, right? Now for example, I have read this 4 by 4 example x in main program because the dimension is 4 by 4, and now as I have already mentioned that it stores value 15913, 15913, and then 261014, 261014, and so on, right? And you see an underline is there, the element 3. Why I am telling you? Well, the next step is that suppose in the main it is declared 4 by 4, but you have defined a 3 by 3, but you have declared 4 by 4. That means these star elements, they are not defined. So according to different compilers, it takes up any arbitrary value, either very high or very low, or whatever arbitrarily it takes up, because you have not defined, right? Or it may be the case, okay. So if this is the case, then according to the same pattern as it stores the 4 by 4, it will try to store these values. So accordingly, it will store 159 and star. So 159 and star, right? The first column, and then 2610 and star, 2610 and star, and so on. Okay, and the star, that is they are dangerous because you are not sure what the star values are, either very high or very low or arbitrarily any value. Now you have declared dimension 3 by 3 in the sub program. Okay, so you are communicating this X matrix to the sub through one-to-one correspondence, maybe in some other name, Y say, but its dimension is declared as 3 by 3. Then what would happen? So what X is returned by the subprogram? If I communicate through argument and parameter X to the sub, and when it get it back, then what does it give you back? Well, so Ij, now it is 3 by 3 in the sub. So 3 by 3, that means 3 into 3, that means 9 elements only. So it will try to pick up only 9 elements from the storage which is in this fashion. So the first 9, 1, 2, 3, 4, 5, 6, 7, 8, and 9. That's why I have put an underline 3. So it will take only the 9 values because it is 3 by 3 here. So it goes like 1, 2, 3, 1, 1, 1 for j, and then 1, 2, 3 for I, and 2, 2, 2, 2 for j, and 1, 2, 3, and 3, 3, 3 for j. Fine. Now, two cases, that first one that you have declared 4 by 4, but you have defined only 3 by 3. So what will be the result? 1, 2, 3, 5, 6, 7, 9, 8, 10. Would it give you back the same 3 by 3 case from the subroutine when you get it back from the subroutine? No, because the first 9 element you see 1, 5, 9, and then 13, right? So 1, 5, 9, and then 13, and here 2, 6, 10, and 14. So 2, 6, 10, and 14, and finally 3. So finally 3. So either if you get it with the star one, this example, then it will write like this. So again the 13 red mark is star, so 13 star, and another red mark is 14 and star, so 14 and star. So in these two examples, either it would give you back this or it would give you back this, depending on your given problem. So when y is called in main, it gives you this, and of course these are the results that you don't want. It is completely misleading, wrong results, because actually you want like this. okay, not this or that. So that's why I mentioned in my earlier video that variable dimension is a very powerful thing, but better not to use it because to keep track of this index problem is very difficult. But for one dimension it's okay. And one more thing, that if you declare the same dimension 4, 4 and 4, 4, then there is no problem. That means even if the dimension is declared say 10 by 10, but in main you are defining 4 by 4 and in subroutine you are again defining 4 by 4, then there is no problem. It gives you back the right results. So I will very quickly see how it really occurs. Okay, I will run a program to check, and the name of the program is check.f. So what I will do, I will run the program twice. So dimension is declared 4 by 4 a, and here C commented is there, n is n minus 1, then I am calling the subprogram check. Okay, so this is the subprogram. You see, yeah, the subprogram is here. So function check n a, and dimension is a, but n n, where n is coming through the parameter, and n n, that means it's not 4 4, so it's a variable dimension I am using. Well, now but what I have done, n is equal to n minus 1, that means n is new n is 4 minus 1 is 3, but that line is commented, so it will not execute this line for the first time when I will run it. So n is 4 because I am reading n 4, and that same n is being used here. That means the dimension of both the main and the sub are same 4. So I told you that there will be no problem. So let us see that what happens when the dimension in both main and sub are the same. Then I can pick up the result that I desire or that I want. That means the communication between the main and the sub, there will be no problem. So it reads the input file from a input from the input file. I am not showing it. So given a, that means what it reads from the input file is like this. Okay, and when it gives you back in the subroutine, after the subroutine is called, then it gives you back the same. So 13, 14, 15, 16, 13, 14, 15, 16, exactly the same. So there is no problem, as I mentioned. But now I am erasing this comment. Now n is n minus 1, that means new n is 4 minus 1 because I have read n to be 4. So n is now 3, and now I am communicating this 3, n equal to 3, to the subroutine, I mean subprogram. So that is the case of as I mentioned, that the variable dimension n is read 4 and the dimension is declared maximum 4 by 4, but in the sub it is 3 by 3. So we are expecting some misleading results. So let me compile and run. So let me compile it first, and then I will run. It will again read the same input set from the, yeah, so it reads the same input from the same file, the same matrix or array, but now when it gives you back in the subroutine, it now gives 159, 159, and then 13, 13, and then 2, 6, 10, then 2, 6, 10, and then 14 and 3. So 14 and 3. So the 9 elements it takes up 4, 8, and 9, right? Because that is the way it's stored in a single array, right? So that's an interesting observation, and it's an warning as well, that if it is a one-dimensional array, then it's okay, you can use the flexibility of a variable dimension, but if it's a two-dimension, then be careful, better not. So that is the program. And now a last problem, that it is a three-dimensional array and how it stores the values. Okay, so three-dimensional, how many elements would be there? The first question. So 2, 3, I, j, k indices, and 2, 3, 3. So the total number of elements will be 2 into 3 into 3. That means 18. So I have written here 1 to 18. Okay. So what is the order of storage now? As I told you that the first I should be exhausted, and then j, then k, right? So when it's a question of k, that would be controlled by I and j, that means 2 into 3, that means 6. So the 18 k values would be 666, right? So here, yeah, so that you see 6 1 and then 6 2 values and then 6 3 values, that is the k. And then j is controlled by I, because I is of the first priority, it exhausts first. So I changes, it has been given the first priority, so it will say that okay, I will change in my own way. I will change 1 2 1 2 1 2 1 2 because it has 2. So I goes from 1 and 2. So 1 2 1 2 1 2, it goes on like that. But j is 3, so for 1 2 1 2 1 2, all are, I mean 1 1 2 2 3 3, then 1 1 2 2 3 3, 1 1 2 2 3 3. So that's the same thing as I followed in case of 2-dimensional array, exactly the same. Here only the added part is that k is also there, and that is how it is handled in 3-dimensional array. Of course, 3-dimensional array we usually avoid, we don't use it in our level, at least we don't need to use it. 2-dimensional is good enough for us, but in principle, in such demanding problem, you can of course use a 3-dimensional array, but then you have to keep in mind that the computer stores the array, 3-dimensional array, in this fashion. Okay, so thanks for watching. ভালো লাগলে অথবা না লাগলে please make comments.